In this example, we will be using half-angle identities to find the exact value of each of the following. First, we will be doing sine of 7 pi over 12, and we will also be doing tangent of 345 degrees. I will say up front, however, that both of these can actually be solved using sum and difference formulas, and if you would like to take a moment in order to try to solve those using those, then go ahead. However, in this case, we're going to demonstrate how you can do this with half-angle. For example, with 7 pi over 12. What we're first going to do in order to apply the half-angle identity for any of these functions, the first thing that you're going to do is to factor out 1/2 out of the angle measure you have provided. For example, if I have sine of 7 pi over 12, and I want to apply a half-angle identity to this, then I'm going to take that angle measure that I have right there, and I'm going to factor a 1/2 out of it. What I have remaining, therefore, will be 7 pi over 6. This angle measure, 7 pi over 6, is the value that I will be using in the actual formula for the half-angle formula. This is why we do that step first. The half-angle formula would take the square root, for sine is 1 minus cosine, divided by 2, and the angle measure that I just found here by factoring out a 1/2 is the one that I will use inside of cosine here, 7 pi over 6. That's the first step of understanding how to use the half-angle identities, is first factor out a 1/2, so your result looks like an angle measure divided by 2, and you can use that value that you have factored 1/2 out of and use that inside the identity. The other thing to understand with the half-angle identities is either if it's going to be plus or minus. It's not going to be both. We do need to determine which one is which. And the way you do that is by looking at what quadrant the original angle measure lies. Not the one that you got after factoring 1/2, the original one. 7 pi over 2 is slightly past pi over 2, because pi over 2 would be 6 pi over 12. And it is less than pi, because pi would be 12 pi over 12. Meaning that my angle measure for 7 pi over 12 is somewhere in quadrant 2. Keep in mind that we are evaluating sine of this angle measure. Therefore, since we know the angle is in quadrant 2 and we're evaluating sine, that means that the result should end up being positive because sine is positive in quadrant 2. So because it's quadrant 2, we will be using a positive here in front. That's the other thing to understand about using half-angle identities. You can factor out 1/2 and use that result inside of the identity. However, look at the original angle measure to determine whether the answer is positive or negative. From here then, we just solve more directly. Here I have 1 minus cosine of 7 pi over 6 divided by 2. Cosine of 7 pi 6. 7 pi 6 is in quadrant 3, so that's negative. And cosine of angle measures of pi over 6 will be radical 3 over 2. So this will be minus square root of 3 over 2. This is technically a valid result because now this has numeric values and no trig functions anymore. However, to clean this up a bit, I will multiply the top and the bottom of the fraction inside the square root by 2, which will give me 2 plus the square root of 3 divided by 4. This, I believe, is a little bit of a better result. However, some prefer to even go a step further beyond that noticing that the denominator is technically a square root of 4, which we should know. So some will also elect to write this as the square root of 2 plus square root of 3 divided by the square root of 4, which is 2. This would also be a valid result. Now let's apply the same concepts to tangent of 345 degrees. Even though it is a degree measure, I'm still going to follow the same steps. So, tangent of 345 degrees. The first thing I'm going to do is I'm going to factor a 1/2 out of 345 degrees. If you factor 1/2 out of 345 degrees, you will get 690 degrees. Now, I will be using that angle measure in my trig identity. However, I'm going to choose to use a coterminal version of 690 degrees because 690 is not within the unit circle. I'm not very familiar with it. So what I'm going to do is I'm going to subtract 360 degrees from that first to find a coterminal one I might be more familiar with, which would be 330 degrees. That's the one that I will use. So we will have the square root of 1 minus cosine divided by 1 plus cosine. And for both of these, I will be using that angle measure of 330 degrees. Keep in mind though, before I move forward, I do need to determine whether this should be positive or negative for the square root. And so I look at the original angle measure. 345 degrees is more than 270 degrees and it is less than 360. So this lies somewhere within quadrant 4. Meaning, because this is somewhere in quadrant 4 and I'm evaluating tangent, tangent is negative in quadrant 4, so my final answer here should likewise also be negative. Now I will move on. I have the negative square root of 1 minus cosine of 330 degrees over 1 plus cosine of 330 degrees. Cosine of 330 degrees in quadrant 4 is positive, and it's positive square root of 3 over 2. This is a fine result to leave it as. However, again, I'm going to multiply top and bottom by 2 in order to clean it up a little bit. And I will instead write this as negative square root of 2 minus square root of 3 divided by 2 plus square root of 3. Personally, I think that looks a little bit cleaner.